In exercise 304, we're returning to a concept that you've looked at before. As you can see, the title is called Linear Functions. Now, linear you've seen before. Linear you know as straight line. That's where the word comes from. Functions you may not be all that familiar with. Function, strictly speaking in maths, a function is just a connection between two or more variables. So it's, I guess in the past, I and your previous maths teachers may have called it an equation. So we have many examples of functions, and our most common variables or pronumerals that we use are x and y. So I'm sure you have seen things like y equals 2x plus 3 or y equals x squared. These are both examples of functions. Now, we look in particular, as this exercise suggests, at linear functions. So this one is linear, however this one is not. That's not linear. A linear function will always have 1 as the highest power of the x. So clearly you can see here the highest power of x is 2, and that's why it's not linear. Can only have x to the power 1 for it to be linear. So algebraically, 1 is the highest power of x, and we will see in the other algebra chapter that you'll do in the HSC course, we will look at functions that are not linear, non-linear functions. And you'll see the power of x will be a 2 or a 3, etc. Our linear functions can also be identified in a graph because they graph to give a straight line. Graph to give a straight line. Now, this example that I've ticked here would graph to give a straight line. However, and some of you will remember, that this graphs to give a U shape, which we call a parabola. Clearly not a straight line, it's a curve function. In all our functions, we have a dependent variable. And the dependent variable in both cases above is the y variable, and you will find that in most of the examples that you will study. It's also the variable that's on this axis. This is the dependent variable. It's like y depends, the value of y depends on whatever x values I put into these calculations. The independent variable there is very commonly x. It doesn't have to be x, it could be a, it could be m, it could be any variable. It is, however, when it's graphed, it's on the horizontal, so it's the independent variable. Now sometimes you get very straightforward questions that show you a graph and they simply ask, what is the independent variable? And variable, remember, is the pronumeral. Variable is pronumeral. You also get questions that ask you, what does it represent? Now that's a very different question. You give a sentence answer to those. Same with gradient. When we have a linear function, and you might recognise this now, y equals mx plus c, and we used to put b there, we're now going to call it c. In that format, you know that the number in front of the x is the gradient. And we know things like when that's a positive number, our straight line points in that direction. And that's a positive gradient. A negative gradient, when we graph our function, our line will point down. The y-intercept, or vertical, y vertical, because this is my vertical axis, or my y, or my dependent axis, and that you will learn comes from our linear equation and has the value c. Just some other terms that I think that you should be familiar with are coefficient. A coefficient is a number in front of the pronumeral. So this is known as the pronumeral, or maybe the variable. If there's a value up here, and in this case there's a 1, that is referred to as the index or power. This number here at the front is this. It's the coefficient. So you'll hear rules that refer to the coefficient. So you need to know what part of the mathematical term it's actually referring to. The constant term has no pronumeral or variable, so it's usually just a number. Just a number. Can be fraction, can be decimal, can be positive, can be negative. I'll leave this video at this point and get you to write down your summary and key points. I'll do the example in another video.